Hello there. So right now we're going to talk about functions and function notation. So first of all, why are functions important? Let me give you this example. Suppose you are a doctor, and a certain type of doctor is an anesthesiologist. And those are super important because when you have a surgery, you want to make sure that the person is completely knocked out. They don't wake up halfway through. And if you give them too much, then they can actually die from the anesthesia. So you don't want to give them just the right amount. Now, the amount of anesthesia depends on how big they are, right? If you have someone who weighs just like 50 pounds, like a kid, you're going to give them a lot less anesthesia than a 300-pound NFL football player, right? So the amount of anesthesia you give is a function of weight. So imagine you're an anesthesiologist and someone comes in weighing 50 pounds. You have some kind of function, and it'll tell you if they weigh 50 pounds, then you want to give them, let's just say, 2 milligrams of the active anesthetic drug. So here, let me just show what this looks like here in function notation. This is your domain. This is your range. So 50 pounds goes to the number 2. Now let's say you have someone come in who weighs 350 pounds. Then it's going to be something different, maybe 20, for example. And let's say you get someone kind of in between. I'm about 200 pounds. And let's say for me it would be 10 or something like that. Okay, so you imagine this function. Now one way we can say this is f of 50 equals 2. Or we can say f of 10 equals 200. Or, other way around. F of 200 equals 10, and f of 350 equals 20. So your domain is your input, your range is your output. Okay, now what if we wanted to go backwards? So if we want to go backwards, then instead of that f notation, we're going to introduce a new notation here. This is f negative 1. So what does f negative 1 mean? So let me ask this question. So what, let me go back. So if I, as an anesthesiologist, gave someone 10 milligrams, how much did they weigh? So f of x equals 10. Now look here at this graph. Let me change colors here. You can see we've got that pair. F of 200 equals 10. Now there's a more concise way of writing that, and that's with that inverse notation. F negative 1 of 10 equals 200. Let me go through here now. We're going to erase these guys. And I'm going to write these arrows now. Oop, let's go keep that arrow. Oh, I just want to keep that, but okay. Let's see if we can just change these arrows around. So now arrows are going this way. And I would say f negative 1 of 2 equals 50. F negative 1 of 10 equals 200. F negative 1 of 20 equals 350. So the inverse function kind of flips that direction around. Okay, let's do this in a table. We've got our x, we've got our f of x. And I'm just making up a couple of random numbers. So if I did something like this, f of 3, what's f of 3? Well, f of 3, 3 is your input, 8 is your output. F of 3 is 8. What's f of 7? F of 7 is 24. What's f of 1? F of 1 equals 100. Okay, now let's do the same kind of thing, except we're going to go backwards. So moving backwards now, let's say f negative 1, 100 is 1. The inverse function of 8 is 3. Inverse function of 11 is 7. Inverse function of 24 is 8. Just reversing the flow that we did just now. Okay, let's do kind of a strange question. Let's do a new table. Okay, so let's switch colors, new table, x, f of x, 1, 2, 8, 9, 30, 81, 74, 21. Okay, so what's inverse function of 81? I'm asking what value of x gives me an output of 81, and that's going to be 2. Okay, so here I'm moving in that direction. Okay, what about this? Inverse function of 21, that's going to be 9. What if I ask the question, f of what gives me 21? Here, these are asking the exact same question. The answer here is x equals 9. When x is 9, my output is 21. Okay, now the one on the test that's a little bit mind-bending is this. F negative 1 of x equals 8. So here we're asking inverse function of what produces an 8? And the answer here is going to be 74. Why? Because I can replace this letter x with the number 74 and make that true. Okay, so here the answer is 74. Let's do another one. Again, these are kind of mind-bending. Inverse function of what is equal to 9? Well, I can replace that letter x with the number 21. Inverse function of 21 is equal to 9, and so that x is equal to 21. Now, the letter x in this context just means something that goes into the inverse function, okay? And the thing that goes into the inverse function is that 21. When I feed that to my inverse function, then I get an output of 9 from my inverse function. Okay, that's it for functions and their inverses.